Roots and radicals. Let's recall that every radical expression contains three parts: the radical sign, the index, and the radicand. Let's recall also that every positive number has two square roots, one positive and one negative. The principal square root is always the positive one. For example, the square root of 9 is 3, because here we are looking only for the positive root, and 3 is called the principal root of 9. As we see in front of the radical sign, we have a positive sign even though we don't write it. But we know that 9 is a positive number, so it has two square roots. And if we want the negative root, we write the negative sign in front of the radical, and this is telling us that here we are looking for the negative square root of 9, which is negative 3. Sometimes we need both roots, so we must write both signs of the roots in front of the radical sign to show that we are looking for both roots of 9. So both square roots of 9 are positive 3 and negative 3. The definition of the roots, let's recall this. In general, we state that if x to the nth power is a, then x is an nth root of a. In symbols is written, the nth root of a is x because x to the nth power is a. For example, the square root of 49 is 7 because 7 squared is 49. The cubic root of 8 is 2 because 2 to the third is 8. And as we see here, a positive number has only one cubic root, which is positive. So the cubic root of negative 27 is negative 3, because negative 3 raised to the third power gives us back negative 27. And a negative number has only one negative cubic root. But the square root of negative 36 is impossible. There is no real root for negative 36. For example, if a is a real number and we square this number, we'll get always a positive result. We never get a negative result as negative 36 is. So we call the square root of negative 36 an imaginary number. So again, let's recall the cube root of a negative number is negative. For example, the cubic root of negative 64 is negative 4 because only negative 4 raised to the third power gives us back negative 64. In general, an even root of a negative number is not real. It is imaginary. For example, the fourth root of negative 81. The index is even number and the radicand is a negative number. So, the fourth root of negative 81 is not a real number because, again, if any real number raised to an even power will give us a positive result and never a negative result as this radicand is. Let's recall also perfect square numbers, which are 1, 4, 9, 16, 25, and so on. These are numbers that we know their square roots. For example, the square root of 4 is 2 because 2 squared is 4. Also, perfect cubes, which are 1, 8, 27, 64, 125, and easily we can get their cubic root. For example, the cubic root of 8 is 2 because 2 to the third is 8. We know this by heart. The square root of a number that is not a perfect square or the cube root of a number that is not a perfect cube is not a rational number. What this means? So, for example, the square root of 2, the square root of 3, the square root of 5. These are not rational numbers. These are irrational numbers, and it is very hard to find the square root of these 2, 3, and 5 by hand, even though the calculator with a square root key will give you decimal approximation for such numbers. So we leave those numbers exactly as they are. And we'll see this during the following work. And also, if the radicand is an unknown number, for example, if we want to find the square root of x squared, sometimes x is a positive number, and when we are looking to find the positive root, we write just x because x is positive. But if x is a negative and we are looking for the principal root, for the positive root, we must write a negative inside of x, in front of x, because we know we need a positive root. So if we place a negative in front of x, negative and negative becomes a positive and we are okay. So those two cases we included in one case by using the absolute value. And the property of the absolute value that tell us that the absolute value of x is x when x is positive and negative x when x is less than 0. Now let's talk about product property of radicals. If the index is an even integer and a and b are positive real numbers, then we have the radical of a product is equal to the product of the radicals. For example, the nth root of the product a and b is equal to the product of the nth root of a and the nth root of b. For example, if we want the square root of the product 25 and 4, based on this property, we can separate them because both of them are positive, as this property states, and the index is 2, is an even integer. So we separate them, and easily we can find their square root. For example, the square root of 25 is 5, the square root of 4 is 2, multiply them together is 10. This means that if we were looking for the square root of 100, we know that the square root of 100 is 10. Okay? And this property tells us that if we write 100 as a product of 25 and 4, and then separate them, because based on this property, the index is even, and those two factors are positive, so that we separate them, we find the square roots of them, and then multiply, and we get the answer back. So slowly. This property is very useful if we want to simplify some radical expressions when the radicand are not perfect square numbers. Let's do some examples. We want to find the square root of 12, but 12 is not perfect square number, so we are trying, based on this property, to simplify it. So I can write 12 as a product of two positive numbers. Okay, 12 is 4 times 3. And I'm very interested to write 4 times 3. 12 is also 6 times 2. But I'm not interested to write 6 times 2 because 6 and 2 are not perfect square numbers. So I write 12 as 4 times 3 because 4 is a perfect square factor. So I know when I separate them, I know the square root of 4. So the square root of 4 is 2, and the square root of 3 is the irrational number I'm leaving as it is. 8. 8 is 4 times 2. Separate. Easily 2 square root of 2. So what is the goal? To write a radicand that is not a perfect square number into a product when one of the factors is a perfect square number. So 18. 18 is 9 times 2. Why I'm interested to write 9 times 2? Because 9 is perfect square number, and when I separate, I know the square root of 9. 18 is also 6 times 3, but I'm not interested for those two numbers. None of them is perfect square, so they cannot help me. So now I will separate. I know the square root of 9. Done. 24. 24, I'm interested to write it 4 times 6, not 12 times 2, not 8 times 3. Okay, I am not repeating this. I'm interested when one of the factors is a perfect square number. Done. 32. Now 32 is 16 times 2. But 32 is also 4 times 8. And 4 is a perfect square number, but it is not the largest, because inside of 8 we know that we have a 4. So 4 times 4 is 16, okay? So we are looking for the largest perfect square factors of a radicand. So now I'll separate the square root of 16 times the square root of 2, happy, 4 square root of 2. Done. Now let me go a little quickly here. So 45 is 9 times 5. Okay, now I will separate. I know the square root of 9. Happy? Done. 50. 25 times 2. Separate. Square root of 25, square root of 2, 5 square root of 2. Done. 90. 90, I am happy when I see a 0 because this is a multiplication by 10. And more happy to see the first digit, which is a perfect square number. So here I will write 9 times 10. So also here I had a 0, but I didn't mention it because 5 times 10, 5 is not perfect square number, so directly I went to 25 times 2. So now I will separate. And as you see, first I write the perfect square numbers in order when I find their square roots, the number will be in front of the other radical. So the square root of 9 is 3 times the square root of 10, done. 75. 75 is 25 times 3. Happy? Perfect square. Separate. Find the square root, and that's it. So you already know that you know their square root. For this reason you wrote this, but we have to show the work. Now, the square root of 300. When we see to 0, we know that there is a multiplication by 100. So 100 times 3. Separate, perfect square number. 10 square root of 3. Done. 400. Here, this is 100 times 4, but 100 is perfect square number, and 4 is a perfect square number. So I know that 400 is itself a perfect square number. So let me show what I mean. So I have 4, which is a perfect square number, and 100, which is a perfect square number. The product of perfect square is a perfect square. So 400 is a perfect square number. And so really it is 20 times 20. So this is 20. Now, if you don't realize that 400 is a perfect square number and you separate 4 and 100, you can go and continue. Separate 4 and 100. Square root of 4 is 2. Square root of 100 is 10. And you get directly. Okay? Now the square root of 51. 51 is a prime number. So the only possibility is 51 times 1. So I cannot do nothing. I cannot simplify. Sometimes we cannot simplify at all. Okay? And this is not something that we have to worry. We have to simplify where we can. And also, 15 is not a prime number, it is a composite number, but if we write 15 as a product of two factors, 5 and 3, none of them are perfect square numbers, so we are not successful to simplify this 15, and we leave as it is. It is done. We cannot simplify a radicand that cannot be written as a factor of one perfect square number and another that is not. Okay? So keeping this in mind, we now are going to combine similar terms. So what are similar terms? Similar terms are terms that have exactly the same radical part. What does it mean, the same radical part? Exactly the same index and exactly the same radicand. So they must have exactly the same index and the same radicand. For example, 3 square root of 2 and 5 square root of 2 are similar terms because they have exactly the same index and the same radicand. So the radical part is exactly the same. Square root of 2, square root of 2. Yes, they are. The cubic root of 6 and 4 times the cubic root of 6 are similar terms. Why? Because they contain exactly the same radical part, the same index, the same radicand. Okay, so yes, they are. But 2 times the square root of 7 and the square root of 3 are not similar terms. Why? Because even though they have the same index, the index is 2, they have different radicands. So they do not pass, okay? So they are not similar terms. And the other, 5 times the cubic root of 4 and the cubic root of 9 are not similar terms. Why? Because they do not have exactly the same radical part. As we see, they have the same index and they have different radicands. Also, for example, the square root of 2 and the square root of 3. They are not similar terms. And also, the cubic root of 8 and the fifth root of 8. So they are not similar terms. Why? They have the same radicand, but they have different indexes. So keep in mind, similar terms are terms that have exactly the same radical part. Okay? So the same index, the same radicands, the same index, the same radicands. So for what we are interested about similar terms, because we want to combine them, and when we combine them, we simplify an expression when they are. For example, 3 square root of 2 plus 5 square root of 2, we combine these are similar terms, they contain exactly the same radical part, and this is as we added like terms. What we said about like terms, we said that like terms have exactly the same variable part. For example, 3x plus 5x, and how we work, we combine the coefficient 3 plus 5, 8x, the same way. 3 square root of 2 plus 5 square root of 2, 3 plus 5 is 8 square root of 2. 7 square root of 5 minus square root of 5, these are similar terms because they have exactly the same radical part. So what is the coefficient here? Here is the coefficient 1, even though we don't see. So we work with coefficient 7. We call this coefficient because this is a product, okay? And 7 minus 1 is 6. And we have 6 square root of 5. So we can work like this. So let's go and do some examples. Example 1. I want to add these two radicals, but as I see, they have the same index, but they have different radicands. But when I see the smallest one, 3, I ask myself, if I divide 48 by 3, the result will be a perfect square number? Because why I'm doing this? Even I can get a square root of 3 in the first term, then I can combine. Otherwise, I cannot combine. So 48 divided by 3 is 16. So yes, I can continue. So I write 48 as 16 times 3. And now I separate. I know now this is 4 square root of 3 plus 1 square root of 3. And I have 4 plus 1, 5 square root of 3. Done. Again, when I see the radicand are not the same, I say in the first side I cannot combine. But when, the smallest one is telling me that if 48 is divisible by 3 and the result is a perfect square numbers, yes, I can continue and combine them. Okay, so I will not stop here, but I will continue. Because 48 is 16 times 3. 16 is perfect square number, and when I separate, I am left exactly what the other term is. Example 2. The square root of 50 minus the square root of 45. So in the first side, I say that I cannot combine, but I will simplify both the radicands. So what is 50? 50 is 25 times 2. And 45 is 9 times 5. Now I separate, happy, because I have perfect square factors. And this is 5 square root of 2 minus 3 square root of 5. As I see, the variable part is not the same, so they have the same index but different radicand, so I am done. So what I did, only I simplified the radicals, and that's it. I cannot combine because they are not similar terms. Example 3. Two square root of 3 minus 7 square root of 27. So let me see. So the smallest one is 3. 27 divided by 3 is 9. So yes, I can continue. 2 square root of 3 minus 7. I will write 27 as 9 times 3. Now I will separate. And now I know here is a multiplication. When we read 7 square root of 27, we know here is a multiplication, but we don't write it. So I have to multiply 7 and 3 together. And what I have 2 square root of 3 minus 21 square root of 3. And now I will work with coefficient. So 2 positive and negative 21 is a subtraction. Keep the sign of the largest. 21 minus 2 is 19. That's it. Done. So you can write like this, or you can write the coefficient. Let's call this coefficient. And clearly you see this is a subtraction here. Example 4. Three square root of 5 minus 5 square root of 500. Okay, in this case the smallest is 5, and I know if I divide 500 by 5 I get 100, which is a perfect square number. Or you can say this is written as 5 times 100, and you'll be left with a 5. Yes, we can continue. Let's write 500 as 5 times 100, or 100 times 5. It doesn't matter. So I have to separate. Five times 10. Okay, is a multiplication there. So I have 3 square root of 5 minus 50 square root of 5. Again, working with numbers, or let's call them coefficient. Okay, so this is a subtraction. Keep the sign of the largest and subtract from 50. 50 minus 3 is 47. Again, you can work. Just factor out the square root of 5. And you'll be left with this. Example 5. 5 square root of 24 minus square root of 8. Now let's see. 24 is divisible by 8, okay, but 8 is 4 times 2. So let's continue separately. Let's see later. Sometimes we can see easily when we see the first, okay, problem, but now let's work. We know that we can simplify 24 and 8. Let's see if we can combine later. So 24 is 4 times 6. And 8 is 4 times 2. Clearly, we see here that we cannot combine. Only we can simplify. Why? Because 4 is a perfect square number. We can send it out, but 6 and 2 will be left inside. Okay? Let me separate. And now I have 5 times 2, square root of 6 minus 2, square root of 2. And I have 10 square root of 6 minus 2 square root of 2. Done. I cannot simplify. So in the moment that you simplify the radicand, okay, in the moment that you write the radicand as a product of two numbers when one is a perfect square number, so what is left is telling you that just simplify and you cannot continue combining, okay, even though you clearly see in the last step. So example 6. Eight square root of 10 minus 4 square root of 250. Okay, so here clearly we can see 10, this is 25 times 10, so yes, 250 divided by 10 is 25, so clearly we can see that we can continue and combine in here. So let me write 25 times 10. Now I will go a little bit quickly here. Okay, so I will not separate, but directly I will send this out. You know now the procedure, so if you do this, you are correct. Okay, so minus 4, don't forget, multiply, the square root of 25 is 5, and leave 10 inside. What do we have? We have 8 square root of 10 minus 20 square root of 10. And now, yes, they are similar terms. I will work with the coefficient. One positive, one negative is subtraction from the largest. 20 minus 8 is 12. And don't forget to write the common radical part. Done. Example 7. 9 square root of 360 plus 9 times 10. The same thing. Okay, 10, 10. Let me rewrite this. 36 times 10 plus 9 square root of 10. I will not separate, but I will send it out. Be careful, some students work fast, but they send 36 outside as it is. So 36 can go outside as the 6, because we are looking for the square root of 36. 36 cannot go outside of the square root. So be careful when you work a little bit faster, just you save one row, but don't send 36 outside. What is 36 outside? Just read. The square root of 36 is 6. Don't forget it is multiplication. Leave 10 inside. So we have 54 square root of 10 plus 9 square root of 10, similar terms. So 54 plus 9 is 63. Done. Example 8. Two, the square root of 40 plus 3 square root of 90. This is very easy, very happy to see this. Multiply by 10, multiplication by 10, 4 times 10, 9 times 10, 4, 9 are perfect square numbers, so we continue. 2, just write 40 as a product of 4 and 10, and 90 is 9 times 10. Okay, you can separate or you just find their square roots. And don't forget, we have a multiplication. 2 times the square root of 4, which is 2. We don't know the square root of 10, we leave it as it is. 3 times the square root of 9, which is 3. And now let's multiply. And combine. 4 plus 9, 13. Done. Example 9. 4 square root of 28 minus the square root of 63. So, let's see. 28 is 4 times 7. 63 is 9 times 7. Okay, happy? We can combine. Now let's see. Perfect square factor, and what is left? If they go outside, the same radical will be left both with 7. So we have 4 the square root of 4 is 2, 7 will be inside. The square root of 9 is 3, 7 will be inside. Multiply. 8 square root of 7 minus 3 square root of 7. Combine. 8 minus 3 is 5 square root of 7. Done. Example 10. Six the square root of 75 minus 5 square root of 12. 12 is 4 times 3, 75 is 25 times 3, so yes. 25 times 3, 4 times 3. Let me go and separate here, just to recall. Okay, and now multiply. The square root of 25 is 5. Multiply. The square root of 4 is 2. 6 times 5 is 30. The square root of 3 minus 10. Square root of 3. It is subtraction. 30 minus 10 is 20. Square root of 3. So similar terms. We combine. So you can separate or you can skip this row. if you want. Okay, but be careful when you skip this row. Again, you cannot write 25 outside or 4 outside. Some students do this mistake. 11. The square root of 75 minus the square root of 27 plus the square root of 48. Now, 75 is 25 times 3. 27 is 9 times 3. Let me write it here. 25 times 3, 9 times 3, 16 times 3. Perfect. Very good. Perfect square number. Perfect square number. Perfect square number. All of them are left with 3 inside the square root. So yes, we can combine all the 3 here. So let me separate. Minus. Plus. Okay, and now the square root of 25 is 5, 3, 4. So similar terms, I have, let me write them now, 5 minus 3 plus 4. So 5 minus 3 is 2 plus 4 is 6. You can work directly. 6 square root of 3. Done. Example 12. The square root of 12 minus the square root of 75 plus the square root of 24. Now, let's see here. 12 is 4 times 3. 75 is 25 times 3. And 24 is 8 times 3. Okay, but 8 is not perfect square numbers. 4 is a perfect square number. 25 is a perfect square number, so 8 is not. Okay, so they cannot be left all with a 3 inside the square root. So instead of this, we write 6 and 4. 4 is a perfect square number. Okay, this is telling us that only those two can be combined at the end. So let me separate. The square root of 12 is be written as the square root of 4 times the square root of 3 minus the square root of 75 is written as the square root of 25 times the square root of 3 plus the square root of 24 is written as the square root of 4 times the square root of 6. And now I have 2 square root of 3 minus 5 square root of 3 plus 2 square root of 6. And the only terms that I can combine are those two. What I have, let me go a little bit slowly here. So 2 minus 5, the common factor is the radical, plus 2 square root of 6. Here I have negative 3. We subtract from 5, we keep the sign of 5. Be careful. And that's it. They are not similar terms. I am done. So this was the lesson for today. So how to simplify radical expressions. Thank you very much.